Hi, I'm Grant Feasy, Senior Design Engineer at AES Solar. We are the partner in Heat4Cool responsible for the design and the supply of the solar thermal system, which provides heat for the absorption heat pump for cooling and heating, and also of the solar PV system, which provides electricity to air source heat pumps, which in turn charge sun heat batteries. I'm going to give you some tips today, which will hopefully make the technologies a bit more accessible to you, answer some questions you have, and hopefully allow you to consider if the Heat4Cool solutions are appropriate for your projects. Firstly, with solar thermal. It's very similar to established solar thermal that you may be familiar with already. You have a solar array on the roof, you have connecting pipework, pumps, valves, and a connection to a heat exchanger or store, which in turn provides heat to the absorption heat pump when it requires. If you have plumbing knowledge and experience and possibly are familiar with solar thermal, you'll have no problem at all working with the solar thermal within Heat4Cool. The key difference is you're aiming for a higher temperature to be available, otherwise it won't work. Typically 75 to 90 degrees Celsius are required for the absorption heat pump to run efficiently. This compares to domestic hot water where anything up to 60 is useful, anything lower can still be useful. This means the amount of solar on the roof should be maximised in relation to the store. The type of collectors used must be considered carefully to strike a balance between cost effectiveness and technical effectiveness. If unlimited space is available, lots of flat plate collectors may be sufficient. Otherwise, consider using different technology types like evacuated tube, evacuated flat plate, or concentrating collectors, for example. Consider the site. And usually solar thermal can be effective quite a way off south and at less than optimum angles. Not so with Heat4Cool. It's really important that you have a good south facing roof with not much shading to get the most heat out of the area available. The specification of components in the circuit should be considered carefully. It is likely that the system will operate at a higher than average temperature for longer periods than solar thermal perhaps normally would. So more durable components should be considered to achieve a good lifespan for the system. Don't overcomplicate things. Extra valves and extra controls in a heat circuit are not strictly necessary to make the Heat4Cool technology work. They can increase the risks of component failures or suboptimal control logic or settings. Stick to a simple flow and return setup where possible for the best chance of success. The solar PV system, the first tip would be, again, it's very similar to standard solar PV that you may be familiar with in a lot of ways. For installation and design, if you're competent and experienced as an electrical technician or engineer, you should be quite comfortable with the solar electrical generation systems within Heat4Cool. The key difference is likely to be with the inverter or charge controller setup. You're looking to provide as much DC solar as possible directly to the heat pump. So often you may only have a charge controller, or within the case of our demo sites, you may have an inverter as well, so that when the heat pump doesn't require heat, you are able to use solar elsewhere in the building or export it to extract the maximum value from the system. Next tip, you can use any panels at all for the solar PV element. Just like any other solar PV system, you can use normal modules, bifacial modules, thin film. You just have to follow the usual design rules for making sure the voltage and the current match up to the controllers that you're using. The final tip, use genuine high quality components. For example, MC4 branded connectors rather than compatibles. Use good quality charge controllers and panels. Hopefully these tips answer some questions for you. If you do have any more questions, please feel free to contact us and we'll answer them as best we can.